Okay, so let me show you which kinds of problems we'll be able to solve by the end of the period, okay? So, if the differential equation looks like this, if your dy dx looks like a function times a function, and one of the functions uses x as a variable and the other uses y as a variable, then we call that kind of differential equation, we call the differential equation separable. What do you suppose separable means? Separated. Able to be what? Separated. Right. Okay, so here are some examples of separables. Dy dx equals xy. That is separable. Here's another one. Y prime equals x sine y. That is separable. Here's another one. Y prime equals e to the x sine y. That is separable. Okay? Here are some that are not separable. So these are non-examples. Dy dx equals x squared plus y. Is it because there's an x squared? No. It's because it is not technically a function in x times a function in y. It's a function in x plus a function in y. So if it was x squared times y, it would be separable. So you can actually put x squared times y over here. This is separable. But x squared plus y is not separable. Okay, here's another one that is not separable. Dy dx equals x plus 1. It looks harmless enough, but it is not separable. So we will not learn how to solve it today. Okay, so let me just show you how you separate them, because they're really, really easy to do. The only hard part is the algebra toward the end. Okay, and some of the plus C garbage. It's kind of complicated. So let's take a look at our first example. I don't need to teach you a method. I just need to kind of show you what I do, and then you'll be able to follow it, I'm pretty sure. Okay, so if you see a problem like this, dy dx is equal to 6y squared x, you recognize right away it's separable, and the reason is you can just kind of rewrite this as y, let's write it as 6x times y squared, see? And so already right away you can see that this is like an f of x, and then this is like a g of y. So one of them looks like a function in x, the other one looks like a function in y. And as soon as you see that it's a product of two functions like that, you know, oh, this is separable. Okay, so how do you solve it? Well, there are kind of two philosophies on it. I'm going to show you my way of doing it after I show you the more popular way to do it. So I'm going to show you the really popular way to do it, and then I'm going to show you my way of doing it. You might like the popular way better, but I think it's a little less formal. So let me show you the popular way. Okay, so what people do is they take dy dx equals 6x times y squared, and they recognize, oh, that's separable. Then what they do is they divide both sides by y squared, and at the same time move the dx to the right. So they're going to put the dx over on the right by multiplying, and then they divide by the y squared on both sides. So basically we divide by y squared and we multiply by dx. Okay, let's pay attention here. Okay, it's been a year since we've learned it. Let's go to integrating now. So what you're going to do is you're going to integrate both sides. You're going to slap an integral bar or integral curl on each side. You can leave the 6 outside if you want. So you're integrating both sides like that. And both of these are easy integrals to solve. Okay? The left side, you're really just integrating y to the minus 2. And the right side, you're really just integrating x. So we're not scared of either side here. Okay, so when you integrate the y to the minus 2, you do that by adding a power. So you increase the power by 1. Now it's y to the minus 1. And then you put a reciprocal of that new power out front, like that. Same thing with the 6x, right? If you're going to integrate that, you're going to basically increase the power by 1. Now it's x squared, and you put a 1/2 in front. Okay, now one of these sides, at least, needs a plus c. So I usually just save that for the right side. Okay? I do not put a plus c on both sides. Okay? All right, so where are we at? We basically have this. -1 over y equals 6 times 1/2 x squared. Let me go and distribute, actually. Let's write it as 3x squared plus 6c. Okay, so what you're looking at here, 6c means 6 times literally any number you want. Any number you want. So you could put 1,000 there, or you could put 1/1000th there for c. It doesn't matter. And so most people would not write 6c. That's silly.
Just write C.
You can just write c. 6 times anything is literally anything you want. So most people just feel comfortable changing 6c to c. I don't feel too comfortable with that. I would rather call it c1. c1 meaning 6 times what c was. It's not the same number, but it's still any old number. So I like to change the name of it real quick. So I'm going to write this like that. Okay? Or you can just change the letter entirely, change it to A or something. Okay, so this right here, what you're looking at, is called the implicit general solution. Why is it implicit? It's implicit because y has not yet been isolated. It is general because there's a c in it. Okay? Now, if you solve for y, you get this. This is an explicit general solution. Why is it explicit? Because y is explicitly known. It is plain and clear what y is. Explicit means clear and obvious. Right? It's clearly stated, openly stated. So this is implicit general solution, this is explicit general solution. Obviously our goal is to have explicits as often as we can. Sometimes you will not be able to isolate y here, it's just not humanly possible. That can happen. But we do our best, and in this case it wasn't too bad, it just, well, I basically flipped both sides over and negated. Okay, let me show you, before we move on, how most people actually, how I actually do my steps on the first opening phase. Okay, so it's kind of like chess, you know, in chess you have an opening move, and that opening move really kind of dictates your success on the problem, right? Like if you're doing chess, you know that the first few moves are very, very important, right? And so in the first move on this, I don't usually feel comfortable moving the dx over to the other side. So what I do is I leave it on the left, and I write it like this. So I go dy dx equals 6x times y squared. I start there. And then I move the 1 over y squared to this side. Okay, so these are the right opening moves. But the difference is I did not move the dx to the right. And the reason is I don't feel comfortable drawing an integral symbol without a differential like that. See how I drew the red integral signs on the last solution? Right here? I do not like writing these unless I write a differential. Okay, so I'm going to put an integral dx on both sides now. Okay, so integral dx. See, integral dx. Why am I doing it this way? Because the integral symbol on its own means nothing. It's when you have integration over a variable that means something. So what ends up happening? Well, the dx cancels here, and I'm right back to what I had before. So I still have the exact same thing on the next step that we had the last time. So now you can see this is the exact same step. The solution will continue on the same. But I think the opening moves are important. I think that when you're showing your work for an AP grader, it's important that you integrate both sides with respect to the same thing. Weren't you taught in algebra to do the same thing to both sides? This looks more like that than this does to me. I'm positive that 99% of people do it this way. It's just how I feel about it. If you want to take the risk and do the left-hand column solution on the AP test, that's fine. But I suggest you just do it the way I did it. Maybe it doesn't matter to the graders, I don't know. Anyway, you're going to get the same answers in the end. Okay, so if you don't mind, I'm going to always do it the second way. Let's go on to our next example. So our next example says dy dx equals xy cubed over the square root of 1 plus x squared, like that. Okay, so the first thing I want to do is decide whether or not it's separable. Okay, so this one's actually pretty obviously separable. You could write this as x times, x over square root of 1 plus x squared times y cubed. Here's your f of x. Here's your g of y. Yes, it's separable. Okay, then what I do is I divide both sides by g of y. Like that. And now I'm going to integrate both sides with respect to x. So I'm almost treating like this integral as like an operator, something I do whenever I want to both sides of an equation. Now let's do it on the right side as well. The dx cancels out. Right? And I like writing this as y to the minus 3. Okay, the left side integral doesn't scare me at all. The right side, a little scary. Let's do the left side real quick. We're going to add a power and put the new reciprocal out front. The new power is reciprocal out front. So this is just going to be y to the minus 2, and I'll need a negative 1/2 here. What about this right side? Do you recognize this thing?
Arc sign.
Boy, it sure looks like arc sine. I think arc sine has a 1 on top, not an x on top.
1 times x, arc sign.
Okay, so I actually fell for it earlier too. I looked at it and thought, oh, I think that's an arc sine, and then I realized, wait a minute, there should be no x on top. Okay, in other words, this is not an arc trig problem. Okay, so what you need to realize is this is a u substitution problem. Let's let u equal 1 plus x squared. So u is 1 plus x squared, which makes du just 2x dx. I see an x dx in the problem right here. Maybe we should isolate x dx. Okay, so let's divide by 2. So 1/2 du is x dx. It's a good review for our little integral quiz on Thursday. Okay, so this is going to look like this now. There's a 1/2 du over square root of u, like that. Alrighty. I'm going to cancel out the 1/2s. Don't need to carry that around. Okay, so I'm left with negative y to the minus 2 equals, and then this is just the integral of u to the minus 1/2 du. Okay, I'm finally ready to integrate. I have negative y to the minus 2 equals, I'm going to add a power, so it's going to become u to the 1/2. I'll need the reciprocal of that 1/2 out front, so that's a 2. And I think I need a plus c, because I didn't do one for the left side. So there we go. And let's put in the u again. So I get negative y to the minus 2 equals 2 times 1 plus x squared to the half plus c. And this is my implicit general solution. If you want to title it, you can. It just means we haven't yet isolated y. Okay, from this point on, isolating y is just pure algebra stuff. And every problem's a little different, you know? So first thing I need to do is multiply both sides by -1, right? Or divide by -1. So basically, this is going to now be a -2. There's a 1 plus x squared. There's a half there. I guess this is now a minus c. But remember what c means. What is c?
Any number.
Any number, right? So -c is just any number anyway. So most people just leave this as plus c. I'm going to put minus c. I don't care. It doesn't matter if you use plus c or minus c. It's literally anything you want. Now, how do I get rid of the -2 power look? Got to isolate y.
For y, multiply both sides by negative.
Yeah, so we can use an opposite reciprocal power. So you could just use like a -1/2 power right there. This would make it a y equals. Okay, so here's my answer, explicitly solved. Y equals 1 over square root of -2 times 1 plus, let's just put -2 times rad 1 plus x squared plus c, or minus c. Either way, plus c, minus c, doesn't matter. I said I would keep it as minus c, so I will. Okay, there it is, your general solution. The graphs of these, like pick any c you want, okay? This graph would fit real nicely in the slope field. Real nice. It's kind of fun to do, actually. You draw your slope field, right? Then you plot one of these, just pick any c you want. C equals 0. And it fits real nicely in the slope field. That's very rewarding. You see that. So what about that c? Are we ever supposed to know what that number is? The answer is yes, if there's an initial condition given. For example, if they tell you f of 1 is 2, like in the warm-up or something, then you would actually want to find the c now. Okay? So let's do one more example today of a separable, and then we'll actually find the c for this one. And this one I'm just doing number 6 for you from your worksheet. Okay? So I'm doing one of your homework problems here. This is your worksheet that's due on Thursday, and the problem says solve differential equation, and you want a particular solution. They're going to actually give you enough information to actually find c. So the function is 4 root y ln x over x if x is, if f of e is 9. I know it looks weird, but they're giving you one extra condition. This is your initial condition, or some people call them the initial values. Okay, so you actually start off the same way as usual. First you try to identify what your f of x is and what your g of y is. So I think we should write this as dy dx equals, for f of x, let's just use all this garbage. And for g of y, let's just use y to the half. Okay, so I've identified my f of x, it's right here, and my g of y, and I realize, hey, this thing's separable, see? Okay. So we divide both sides by g of y. So now it looks like this. Then we integrate both sides with respect to dx. I'll write this as y to the minus 2, or y to the minus half. So put an integral dx on that side. I'll leave the 4 outside. Do an integral dx on the right side. The dx's cancel as before. Okay, so I'll be adding a power to this y to the minus half. And now it's, hold on a second. All right, I'm a mathlete. Okay, you're going to add one power, right? So this is y to the half and a reciprocal out front. Don't worry about the plus c, you can do that on the right. Ooh, we got a new integral to solve. I need to solve this thing. You can solve it by parts, I believe. Although what I think I would do is just recognize that technically 1 over x is the derivative of ln x. So this makes for a really good substitution situation. So you could just let u equal ln x, and du is actually 1 over x dx. It's like perfect situation. So this integral is literally just the integral of u du. Look how simple that is there. Yeah, it's raining. Okay. And let's go ahead and integrate u du. If you want to cancel out these 2's, you can. Let's make that, let's divide by 2. I don't like carrying extra coefficients around. Okay, so I was going to integrate u du. So it's just going to be a 1/2 u squared, right? So it's y to the half equals 2 times 1/2 u squared plus c. And then let's distribute. Okay, I've got a 2c here, but we said that that's just any number, so I'll just put c1. You can write 2c if you wish. Okay, now, I would like to eventually get y by itself. I also have some initial conditions, but before you get y by itself, I think you should find c right now. If you square root, your c is going to get buried under a pile of rubble, and then you're going to have to free him up again. I think you should plug in your initial condition right now. So I'm going to put a big fat note here. Plug initial conditions.
You have to put your u back in.
Yeah, I do. I do need to change this back to an x squared, or a ln x here. You're right. But plug initial conditions into this implicit form. Why? Because, I'm going to say it again, if you square both sides, your C1 is going to get stuck in a radical, inside of a radical, and you're going to have to free it up again later anyway. So I say we should plug in the E and the 9 right now. So remember, the initial condition was f of E is 9, and you guys laughed when I wrote it. Those were the givens. So that means we're going to plug in E for x and 9 for y. So it's 9 to the half equals ln E squared plus C1. This is just 3 equals 1 squared plus C1. So what is C1? 2, that's correct. Okay, now we can go back and rewrite our general solution. It is now a particular solution. And now you can square both sides. Give me 1 second. I want to say something and then I'll call on you. Unless I made an error. Did I make an error? Okay. Okay, so what is this thing called? This is the particular solution. But it's implicit, meaning we hadn't solved yet for y. And this is the particular solution, and it is explicit. Y is completely isolated. We can actually graph this if we wanted to on our calculator, and it fits the slope field. Okay, question?
Couldn't y the 1/2 equal -3 and then you have a different c?
No, anytime you see a to the half, it means the principal square root of a. So it literally means the positive square root of 9, and so you would not do it plus or minus. Okay? Now if you're solving this, a squared equals 9, that has 2 solutions. But if you see a to the half equals, or 9 to the half equals what? That's just one answer. Good question. Okay, so what would be really rewarding, it's a lot of work, but what would be really rewarding is to actually sketch the slope field for this gnarliness. This thing's awful, but imagine sketching a slope field for it, and then finding the point E9 and drawing this curve. It would fit perfectly in the slope field. So, I mean, it looks really cool when it's done. I still need to get you a slope field generator on your calculator. You could actually do this on your calculator. You could just graph this, the free Q slope field, and then go back to Y1, enter this, and it fits beautifully right in the hash marks of the curve. Okay, so you guys now know how to do number 6 on your worksheet. And it was one of the harder ones, so hopefully you followed that.